Alright class, I wanted to show you how to use this little handy tool that I gave you to figure out the electron configuration of any given atom, especially small atoms. If you get really big atoms, this won't work. But for now, it will work for some of the ones we want to talk about. So let's take oxygen, for example. So if we think about oxygen, alright, and we put oxygen, right, that's not drawing. I think oxygen. Oxygen is on your periodic table. You'll find that it's got an atomic number of 8. That means it's got 8 electrons. Basically, all those electrons have to have a seat in the electron orbitals. So we'd say, we just start in my little chart here, and we just fill it in as it goes. So we'd say there's one here, and there's one here. We go around in that first energy level, and that's all the room there is. We go up to the second energy level. There's one there. There's one there. We go around, and now we have some other orbitals. These are the dumbbell-shaped orbitals, and there's really 3 of them, each holding 2, so you can see the whole 6. So we've got one there, and one there, and one there, and one there, and that is 8 electrons in their seats. So how would we write this? We'd write this like this. The 1s2 orbital is filled. Remember, that's spherical, so you'd write 1s2. That tells us that's filled. We see the 2s2 is the next one that got filled, so we'd write 2s2. And we move on around here, and we come to 2p4. And you see we've got 2, 4, plus 4 more. There's 8 electrons. This is the electron configuration for oxygen. It's really that simple. So yeah, notice here, again, I had this, right, 2p4, and that's right up here. Very good. Let me show you something else. Let's take something a little bit more difficult, like gallium. Gallium's a little more challenging. Gallium's got the atomic number of 31. That means it's got 31 protons. It's got 31 electrons. So again, all those electrons have to have a place to sit in the atomic orbitals. So we said there's 30. We got to keep track here. 31. All right. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, up into the 4th subshell, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. There's the last one. Now remember, it's a little weird. The 4s orbital is actually easier to fill. It's less energetic than the 3d orbital. So we fill up the 4s before we fill up the 3d, and that's why I put that in that thing. So how would we write this? This gets a little longer. Again, we got 1s2, 1s2. We've got 2s2 filled, s2, right? See, that's right here. All right, we've got 2p6 filled up. All right, so that's 2p6 is filled up there. We go around up into the 3rd. We say 3s is filled, 3s2. We go around to see that our 3p is also filled up, 3p. Whoa, that's messy. 3p6 is filled up. We go to 4s2, s2, because that one's filled up. Now we hit that 3d again. It seems a little out of order, but that's just because it's harder to fill up that 3d10. And finally, we have 4p1. Now that's a little bit messy, but if you count up all these 2, 4, 6, 10, 12, 18, 20, 30, 31. There's our 31 electrons. So we've done this right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. That would be the electron configuration for gallium. Okay, I'll leave it with that for right now. I'll maybe do another one or show you how to look at the periodic table and do the same thing. But this is kind of a first step in making these electron configurations. Hopefully that is helpful.